Hello class. Today we're going to look at section 2.6, adding and subtracting expressions. This is one of those things, this is going to be important throughout the whole year. We're going to be doing a lot of work with expressions, and being able to write them in their simplest form will be very important. We have two main learning targets today. We're going to use a distributive property to combine like terms. We're going to simplify expressions with several variables. Let's get started. So first I want to talk about like terms. All right? Let's define like terms. Like terms are terms that contain the same letter variable, or variables, which are raised to the exact same powers. Okay? Their coefficients may be different, but they're the same variable raised to the same power. So 2x and 3x, like terms. But 2x and 3x squared would not be like terms. All right? They give the example of 3a and 2a. They are like terms because although they have different coefficient, remember the coefficient is the number in front of the variable, all right? Although they have different coefficients, they have the exact same variable, a, and it's raised to the same power. So I'd like to give the example of apples and bananas, all right? Let's say you went to the grocery store and you wanted to buy some fruit, and you bought 2 apples, you bought 3 bananas, and then at the end you're like, you know what, I need a couple more apples. I went and got 3 more apples. Now, if I went and bought this from the store, and I went home to my wife, and she's like, hey, what'd you get from the stores? And I said, oh, I got 2 apples, 3 bananas, and 3 apples. She'd be like, wait, what? What do you mean 2 apples and 3 apples? Okay? That's why it doesn't really make sense to say it as it is here, 2 apples, 3 bananas, and 3 apples. Instead, what we like to do is we like to combine the like terms of A, or apples. So instead of saying 2 apples, 3 bananas, and 3 apples, I can just combine the apples into saying 5 apples and 3 bananas. Right? So if I go home and I tell my wife, oh, I got 2 apples, 3 bananas, and 3 apples, she's going to look at me like I'm crazy. But if I go home and say that I got 5 apples and 3 bananas, that would actually sound normal. Right? So we like to combine the like terms. We like to say it as simply as possible. Notice we do not combine 5 apples and 3 bananas into something that looks like this. Now you're saying instead of getting 5 apples and 3 bananas, you got 5 apple nanas or banapples. It doesn't make sense, all right? So since these two are not like terms, that's as far as we go. So to sum this up, we combine the like terms, in this case 2 apples, 3 apples, into 5 apples, but we do not combine then apples with bananas. Next, it's also very important to only combine terms that have the same variable raised to the same power. All right? If you had a PS3 in your house, or a p to the 3rd power, and you also had a PS2 in your house, or a p to the 2nd power, you wouldn't go to your friends and be like, hey, I got a PS5 in the house. All right? You can't add those together. We can't say something like a PS3 plus a PS2 equals a PS5. All right? It just doesn't work. The PS5 hasn't even been released yet. And even if it had been released, it's not like you can take the parts from a PS3 and the parts from a PS2 and somehow combine them together into making a PS5. It doesn't make sense. You also can't say something like this. I have a PS3 and a PS2, so I have 2 PS3s. No, you don't. You have a PS3 and a PS2. They cannot be combined, all right? So the other thing we need to look for when combining like terms is that they have the same variable, which these two do, but they're raised to the same power. So let's look at a couple examples. All right. Couple examples. Let's start with this. Let's say we had 3x plus 4, and we're going to add to that 2x minus 1. Now, I have seen students do this in a vertical method, and I've seen students do this horizontally. So let's do both just to see what each one looks like. Let's start with vertical. With vertical, what we like to do is we like to take our two expressions and line them up vertically. When we line them up vertically, we like to put like terms over one another. So I have my 3x plus 4, and I'm adding that 2x minus 1. So I would put the 2x right under the 3x, because 3x and 2x are like terms. They have the same variable raised to the same power. Then I would put that minus 1 right under the 4, because constants, or just plain numbers, are like terms. And then we just add straight down. 3x plus 2x is 5x. 4 plus negative 1 is 3. And that's our final answer. So that would be vertical. We line up our like terms, and then we add them straight down. Horizontal is the same idea, we just group it a little bit different. So we have 3x plus 4 plus 2x minus 1. And instead of putting my like terms over one another like I did in the vertical strategy, I'm just going to group them together. So I know that 3x and 2x are like terms because they have the same variable raised to the same power. So I'm going to group those two together. So 3x plus 2x. Then we're going to add to that my other grouping, in this case the constants, 4 and negative 1, so 4 plus negative 1. Simplify each grouping. 3x plus 2x is 5x. 4 plus negative 1 is 3, which gives me my final answer. What you should notice is that the answers are exactly the same. However, just different methods. Now you'll also run into subtracting expressions, which actually is a little bit more difficult. You may remember from earlier in chapter 2. Actually, let's go ahead and write the problem. Let's do this one. 4d minus 2 minus 5d minus 3. Now, you may remember from earlier in chapter 2, we created a new rule about subtraction. And my rule about subtraction is don't subtract, right? Don't subtract. Let's write the rule up here. I told you to don't subtract. Add the opposite. Don't subtract, add the opposite. So let's do that here. Instead of doing the subtraction, let's add the opposite. So here's what we're going to do. We write our first grouping exactly the same, 4d minus 2. All right, then we have minus 5d minus 3. But again, we aren't going to subtract. We're going to add the opposite. So we need to make two changes. First, we change our subtraction to an addition. All right? The second change we need to make is we are going to take a negative 1 and we're going to distribute that to both terms in my second grouping. If this second grouping had more terms, we would still distribute that negative 1 to every single term. So let's do that and rewrite the problem. So my first grouping is unchanged, 4d minus 2. Now we have plus. Negative 1 times 5d is negative 5d. Negative 1 times negative 3 is positive 3. And now what we have here is an addition problem. I'm going to use the horizontal method because that's the one I like better. So let's group my first group of like terms, which is any like term that has just d attached to it. So this will be, use that same color. Use that. 4d plus negative 5d Then my second grouping will be my constants, -2 and 3. So -2 plus 3. So we end up with 4d plus -5d is a -1d, plus -2 plus 3 is 1. So -1d plus 1 is my final answer. So don't subtract, instead add the opposite. Another thing you'll commonly see, a common type of question for this section, is when we run into something like this. Let's see if I can draw a shape correctly here. See if I can remember how to do this. Alright. I want a triangle. Let's say we have a triangle. Alright, and they tell me one side of the triangle is 2p minus 5s. Another side of the triangle is 3s minus 3t. And the hypotenuse of the triangle is 5t minus 4s plus p. And what they're going to ask for here is the perimeter of this triangle. Now hopefully you remember how to find the perimeter of a triangle. To find the perimeter of a triangle you add, or the perimeter of any shape I should say, you add all the sides together. So we have 2p minus 5s plus, I'm going to run out of space, 2p minus 5s plus, let's do this side next, 3s minus 3t plus, and then my final side here, 5t minus 4s plus p. And we need to add all of this together. Now the key here is to combine like terms. Again, like terms, same variable, raised to the same power. So let's go in alphabetical order. Let's start with the terms that contain p. So first, let's add together any p terms. We'll do that in orange. So we have 2p, that doesn't have p, that doesn't have p, that doesn't have p, no p, no p. Here's p. So we'll have a 2p plus p. Next we'll have, let's go with the s next, negative 5s, 3s, and negative 4s. So we need to combine all those, negative 5s plus 3s minus 4s. And last, my terms that contain t, negative 3t, and 5t. Now it's just simplifying. 2p plus p, 2p plus p is 3p. Negative 5s plus 3s is negative 2s, minus 4s is negative 6s. And negative 3t plus 5t is 2t. So the perimeter of this triangle is 3p minus 6s plus 2t. So again, when we are adding or subtracting expressions, it's all about combining like terms, okay? Combine like terms. Get your homework done.